All right, this is a video on two-variable inequalities with a challenge and a real-world connection problem. I encourage you to pause this video and try these on your own and then check back in and see how you did. So we'll do the challenge one on the left first, and I already have a bunch of it set up for you just to save some time in the video. But let's be clear about what's being asked here. We are being asked to graph this inequality. Y is less than the sum of two separate absolute values, x minus 3 and then x plus 2. And I've highlighted one yellow and one blue. So the way I want to graph this is by actually plugging in points and making a table. And that's what I've started ahead of time, is plugging in some of those points. So I have all the yellow components for each value of x here. And I have all the blue components for each value of x here. And I did that just to save some time in the video. But I also did it to show some patterns. So look at the yellow patterns. You can see that, like we might expect for an absolute value graph, it drops 8, 7, 6, 5, 4, 3, 2, 1, 0, and then up to 1, and then up to 2. And where does it reach 0? It reaches 0 at 3, which is for the same reason that there's an x minus 3 in the inequality. And then similarly, looking at the blue pattern, 3, 2, 1, 0, 1, 2, 3, 4, 5, 6, 7. And where does it reach 0? It reaches 0 at minus 2 for the same reason that there's a plus 2 in the inequality. So just see some patterns. I wanted to point those out. But let's actually find the actual values for y. So we have an 11, 9, 6 plus 1 is 7, 5. And then something really interesting happens. We just have a whole string of 5s. And that's because the yellow pattern is continuing to decrease and the blue pattern is increasing at the same rate. And so those cancel out and keep us just at that 5 level for a while until they are both increasing, and then the sum starts increasing as well. So let's go ahead and graph our function here. And I think we can just have a scale of 1s. Let's see if we can get it to fit. So negative 5 up 11, 1, 2, 3, 4, 5. 2, 4, 6, 8, 10, 11, way up here. And then we're going down by 2s, 9, 7, 5, and then we just stay at 5 all the way until x is 4, then we go back up to 7, and then 9. And so we can go ahead and graph this function here. And that would continue. And just to be clear, this is a graph of the boundary of the inequality. Okay, we are ultimately graphing an inequality, but what I've graphed so far is just the boundary line. And I can make it a dashed line here. It's easier if I do that after the fact, like so. And then we just need to think about what side of the boundary line do we shade? So do we shade the bottom or the top? So let's pick a point. Let's pick 0, 0, and let's say, is 0 less than the absolute value of 0 minus 3 plus the absolute value of 0 plus 2? So is 0 less than the absolute value of negative 3 plus the absolute value of 2? And it is. 0 is less than 5. So 0, 0 checks out. So we can shade everything below and up to the boundary line, but not including the boundary line. That's why the boundary line is dashed. Okay, so all of those points in that shaded zone are legitimate solutions for this inequality. All right, we'll do another one over here, and let's define our variables. It looks like we have 24 hours available over the next week to either work at my part-time job or get some exercise. And we want to write and graph an inequality that shows the amount of time available for each activity. So let's write the inequality first, and let's define our variables. Let's have x be work hours, and let's have y be exercise hours. So we'll have work down here, and we'll have exercise on the vertical axis. And we are going to have a relatively straightforward inequality. Just the sum of those 2 hours has to add up to be less than or equal to 24 total. Okay, so we can graph that up in a pretty straightforward manner. And we'll graph the boundary line first. And the boundary line is x plus y is equal to 24. And we'll just use the intercept method. If x is 0, y is going to be 24. And similarly, if y is 0, x is going to be 24. And we can connect those with a straight line. So let's get that guy going in there. And then we need to think about which side do we shade. Do we shade the above to the right or below and to the left of that line? And I think we can see that we can shade below and to the left, because if we put in our test point 0, 0, 0 plus 0 would be less than or equal to 24. So we're going to shade everything down and to the left. But now we need to think about, are all those points actually valid in this real world situation? For example, is this point valid? This point right here is 3, 15. 3 hours of work, 15 hours of exercise. Yep, it meets my requirement. However, is this point valid? 12, negative 6. 12 hours of work and negative 6 hours of exercise? That doesn't make sense in this real world context. So let's specify the actual final solution would be in this, in this shaded triangle that is in the first quadrant. Okay, so that would be our actual final solution for this real world situation. All right, we did it. That's a good place to stop.